Hello and welcome to my channel. This is Maro with Code with Maro. Today we're going to be looking at the beginning of the Dart programming series. Now, this series is going to cover Dart programming language from the very basics to more advanced concepts in Dart. So it's going to cover all through the fundamentals you're going to require to start off as a Dart developer or Flutter developer. Now, Dart is a null-safe, strongly typed object-oriented programming language which can be used to build multi-platform applications with Flutter. It can also be used to build server applications and web applications. Now, when I say multi-platform applications, I mean it can build applications for mobile phones, as Android and iOS. It can build for Mac OS, can build for Windows OS. It can build for Linux, and also can build for the web. Now, we're going to go straight into what we'll have to look at today. I'm going to start by looking at variables and data types. Now, before that, you see this void main here is the entry point for any Dart programming language, any Dart program you have. Okay, so whatever is enclosed within this curly braces is what is going to be executed when we try to run the program. So now that that's out of the way, let's dive straight into what variables are. Now, variables are simply containers, right? So more like you have a cup that can hold water, right? So that's like a variable. So a variable could be the cup, and whatever is inside the cup is what the variable holds, right? So it could be water, it could be Coca-Cola, it could be Pepsi, it could be wine, it could be whatever, right? Anything you want to put in the cup goes into the cup. So that's what variables are. So for Dart, luckily we have what we'll call the var keyword. Now the var keyword can be used to declare variables, right? So you declare a variable, say age, and you say age is 54. Now age 54, age is declared as 54, and 54 is an integer, right? Which is the first data type we'll be looking at. So this now, with the var keyword, we'll be able to declare variables and infer the types. Now, even though Dart is a strongly typed language, it still allows us to infer types, right? So your types can be implicit or explicit. So that means when you declare a variable, you can either decide what data type that variable would hold, or you allow the program infer that for you. So if we do this with the var keyword, we can declare the data type, and if we decide to print now age dot runtime type. Now runtime type tells you the type of that variable at runtime. So when you check that variable, what time is it holding at runtime? Runtime is when the code is actually running. So run this code by saying dot play dot dot. So you type dot and you type the name of your file dot dot. When you run this, it tells you the runtime type of a variable age is an integer, right? But you see that we do not have integer here. We don't have the keyword integer here. Now let's see if we can actually change the type of this variable as we move on. So we say age is now going to be equal to 3, right? Now you see that there's an issue here. Now it tells you that the value of type string cannot be assigned to a variable of type int. Now what happens is when you use the var keyword, it allows you to infer the data type. But once a data type is inferred at a point, it can no longer be changed to another data type. Now, this data type we're looking at here is a string. Now, for us to be able to change between data types at compile time and runtime, what we'll use is the dynamic keyword. So when you use the dynamic keyword, you're going to be able to switch between data types at runtime. So dynamic, we're going to say, let's just call it object. Object is, yes, let's say 3. Okay, I have to enclose this with either double quotes or single quotes to show that it is a string. Now that I have done this, I can run through and get the runtime type of the variable I have as object. And if I run the code now, it's going to tell me that what I have is a string. Now see what happens here. If I decide to make this object an integer, right, by making it into a number, what happens? For no red lines, right? Now this is because with the dynamic keyword, it's telling you that, well, it doesn't matter. You can start off as an integer and go and become a string. That's all good and fine, right? But for the var keyword, it's telling you, yes, I'm a variable, I'm holding something. But as long as I am holding water, you can only add water to me. Don't give me anything else to hold. Once I start holding water, don't put anything else in me. But for this, it's saying, well, I'm a cup, right? You can do whatever you want with me. You can add water now, take out the water and put in Coca-Cola. That's all good and fine. It's all up to you. And if we run this, it's going to tell us now that object is now an integer. So you see that at some point, let's prove this, right? We're going to print this twice and say at some point this was an integer and at some point this was a string. And then we're going to have first string and then integer. That means it's telling us that the first time we checked the data type of the object, it was a string, and now we checked it, it's an integer. So let's go into strings and integers in more detail, starting with strings. All right, so now that we have strings, let's say we want to add this into this. So let's say okay, we're going to declare the keyword string now directly. Okay, let's take this out, and then we'll declare a string which we'll call intro. Okay, and we'll give it we'll say my name is Maro and I am. Now we want to be able to add this age that we have here into this. So for us to do that, we're going to use string interpolation method and add the object age. All right, I am age years old. Now when we do that, whatever the value of age is going to be the value that we printed out when we decide to print out intro. So we'll print intro. And now, because of the fact that even though this is a string, right, you see that it's a string, and we said that strings are a combination of letters. Oh, did we say that yet? No, we haven't said that yet. So strings are a combination of letters, right? So they are enclosed in either double quotes or single quotes. Now that we've said that, we want to be able to add something else that is not a string into a string, or any other object at all, right, into a string. What we simply do is use the $sign, right, before that object, and then we can include it to what we have. So if we run this, it's going to print out my name is Maro and I am 54 years old. Now you get a better sense of this if we are able to type all of these when the program starts. Okay, so let's do a little something here. We'll clear this up first, and then up here we're going to, when the program starts, we're going to ask the user to enter their name. So we'll use a standard output. All right, standard output dot write line. So we're going to write a line that says, hello, what's your name? Now you see that there's a problem here, right? It says it's expected to find something, but it's not finding it. Now the reason is because we're using single quotes here, right? And we'll have another single quote. So it looks as this as one single string literal. Now one way to eliminate this would be to use double quotes from beginning to end here, and this single quote is no longer a problem. Now another way is to leave the double quotes in, and then you put this before the other quotes there. That's part of the what's, right? So when you use this, it no longer sees this as part of the quotes for this. Now sees this as part of the string. Now, so we're going to ask the user to enter the name. So their age now will be, their age is going to be the input that they're going to put in. So we'll read it out by saying standard input dot read line sync. So whatever the user enters is going to be their age. And then we can also continue. Let's just keep this up and say, and ask them, how old are you? All right. Okay. Now we're going to say, oh, sorry, this is still age. So we can change this to name. Okay, name. We're going to use name. Okay, name. How old are you? All right, and so when we ask how old the person is, we can then take another input. So just copy this and paste here, and then I'll change this to age. So this is going to read the next input from here, and it says, oh, okay, this is my age. And then now the reason why I'm doing this is because I want to show us something about type conversion, right? Now we could actually print out whatever the user enters directly, and we say print hello name, you are age years old. Oh, that's years old. Now if we have this, we can take this out and then save, right? So let's run the code. Or I already ran clear, so let's run the code again now. So we have dart play.dart, and that asks first, say, oh, what's your name? Well, my name is Maro, so I'm just going to enter Maro, and he says, okay, Maro, how old are you? Well, I'm 15 years old. Say, hello, Maro, you are 15 years old. Now, just looking at this, you think this is actually an integer, right? But if you actually decide to print out the data type for that, you see that it is not an integer. So print age dot runtime type, and if you do that, okay, for us to save our time, we're going to prevent the computer from asking us our age now. Okay, I will just go straight to how old are you as well, and take this out as well. Right, so we save and we run, and then it says how old are you? I enter 15. Now you see the runtime type for 15 comes out as string. Now if we want to change this, right, all we need to do is do what we call parse int, right? So we're going to pass this entered string as into an integer. Right, so this is going to be, let's say, int parsed age would be int.parse age. All right, now because this is expecting a string, right, and that is null safe, there's a possibility for this age to be null, right? So when the age is not null, that's when this will run. So we're checking to ensure that it's not null. So we want to now print the past age, the runtime type of the past age at the time the program runs. So we'll go and we say, what's your age? We're still 15. The 15, and it says int this time, right? So you see that we've been able to convert the type of string to an integer. Now this brings us to another data type we have, which is a double, right? So doubles are numbers as well, but this time around they are not whole numbers, they are fractional numbers. So any number that has a decimal point is a double. So we can declare doubles by just typing the keyword double. Say decimal is 15.5. Now if we decide to make this 15.5 as to take 15.5 as a number, let's say int number is 15.5, you see, gives us an error and says a value of type double can be assigned to a variable of type int. Now this is because Dart is so smart and it can determine the type of data that we have and also check what we are trying to initialize it with, and it tells us, oh sorry, that cup can only hold Coca-Cola, why are you trying to put water in it? So now in this case the water is double, Coca-Cola is the integer. All right, so this wouldn't work. Now to convert this from being an integer, from a double to an integer, we'll take all of this out now. Okay, don't need this for now. To convert this to an integer, we could go different ways, right? So the easiest way to do it is just to call, say, let's print decimal.ceil. Okay, now what this does is it's going to round this number up to the nearest whole number. And when you save this and you run, what you're going to have is the nearest whole number, which is 16, and 16 is an integer. All right. Now let's assume that we have a string which is going to be a double, right? So we say decimal number, and this is, say, 12.4, right? Now this is a string, but we want to get it as a double, right? So we're just going to print out the runtime type now with the conversion, everything together. So we're going to do print decimal number. Oh, sorry. Double dot parse decimal number. All right. So double dot parse is a method that takes a string as a source. All right. Now, when that string is passed in, what happens is that language looks at it and then turns it back to a double for us. So we're going to take this out for now because we do not need them, and then we save and run. Now that gives us 12.4 as the double, right? Now it seems like it's printing the exact same thing. So what we're going to do now is add runtime type. And when you add runtime type, you then be able to tell that yes, it is no longer a string, it is now a double. So that is how you convert from strings to integers, from integers to strings, okay, we've not done that for strings, right? So okay, to convert from any format or any data type to strings, all you need to do is call the dot to string. So we have int 54, int number, let's just say number 54, and then we're going to print number dot to string dot runtime type. And when you run this, it's going to give you the runtime type as string. Now, you can have a we have different methods on different data types, right? So there are different functions you could call on different data types to execute different functionalities for you. So for strings, we can have a name. So let's say string name. Name is Maro. But I want this name to appear in uppercase, right? So I print name dot to uppercase. You could also make it appear in lowercase or whatever you want. So that, and you have the name printed as all uppercases. So with that, we've been able to look at strings, doubles, and integers. We're going to move on to more data types now. And we're going to move on first to booleans. Now, booleans are simply true or false statements. So you could have a bool, you declare them by using the keyword bool, and I would like to say is hungry. Is hungry, and it's either going to be true or false. So let's say false in this case, since I'm not hungry yet. So bool is hungry is false. Now this is used to check the trueness or falseness of a situation, right? So when you have booleans, you're trying to check if a condition is true or false. So that's what booleans generally do. Now we'll be looking at collections, and we'll be starting with lists. Lists are an ordered group of objects in Dart. Now to create a list, you can either type the keyword list, right? Or you could just use the final keyword and then you give it a list a name, say list, and then you ensure that you have your square brackets. Now the square brackets is what determines that what you have within it is a list. Now list items are separated with commas. Now this list is going to be a list of dynamic variables. That means whatever we'll pass into it is going to get accepted. So we can have 1, 2. So this now is a list of numbers, but since it's a dynamic list, we can also add words. So say tree, and we can also add the boolean variable, which is false, right? So all of these will work on this list. Now we're going to take this back out and leave it as a list of numbers for now. So we're going to take out the final keyword as well in list and list of integers. So this tells you that this is only going to accept integers. It says it's a list of integers. Now what we're going to do is we need to understand that even though we have 1, 2, 3, 4, and 5 here, now when you have a list in Dart, and practically every programming language on earth, your first element
is, even though it's the first element on the list, it has an index. So list items are identified by the index of the elements there. Alright, so what we can do now is we can have, let's say we want to get the first element on this list. The first element then is going to be, so let's print it out. So print, you think naturally that the first element should be 1, right? So print the first number. That's what it says, right? So okay, let's change this up a little so it doesn't confuse us. So let's make it 5, 8, 9, 5, no, 6. Yes, 5, 8, 9, 6. That's good. All right, so if this says print the first number and you try to print the first number, let's see what happens. And you see it prints the first number as 8. Well, if you look here, you see that the first number is not 8. Now, the reason why this is happening is because when you have a list in Dart, it checks the elements in the list and it assigns an index to all of them. Now, the first index of an element is always 0. So the index will go 0, 1, 2, 3. So the index of 0, the number that's on the index 0 will be 5, and so on. So index 0 is 5, index 1 is 8, index 2 is 9, index 3 is 6. Now, even though there are 4 elements on this list, the index of this list ends at n minus 1. So the index of any list will always end at n minus 1. Now, that is where n is the total number of elements on the list. So to prove that, we can just say, so to get the length of elements in the list is list.length now minus 1. So this is our n, okay? So list.n is n, or the length is n, and then we'll subtract 1. That will give us the last element on any list at all that we have. So if we do this and print again, we're going to have the last element of that list, which is 6. Now we can also add elements to a list, right? Right now we have 4 elements on this list. Let's say we want to add an element to the list. We could just simply go list.add. That's one of the methods in the list. List.add, say 5. No, let's add 23. Good. So if we add this, and then we'll still we remember this is going to execute first, then this goes before here. So this time around, before adding this gets added to the end of every list. So whatever element you're adding to a list is added or is appended to the end of the list. So this will then make up the 4th index on our list. Now if we print the same last element, this will now be our last element on the list, which is 23. Now let's say we want to add this, but we do not want to add it at the last element, right? So to do that, we can actually insert, right? So we come here and instead of list.add, we have a list.insert. So insert. Now for us to insert, it takes 2 arguments, right? One is the index where we want to insert, and then 2 is the element we want to insert at. So let's say we want to insert this at the second index. Now if what we're going to do now is we're going to print this, and we're also going to print the entire list, right? So let's take this out from here. Now if we save this and run, yes, run that, we're going to have the last element is still 3, and now you see that 23 is positioned at the second index, because that's where we said we asked the list to insert that number at. So we've inserted 23 at index 2. Now, just as we can add elements to a list, we can also remove elements, right? So we'll take this out again, and then we're going to remove elements from a list. So list.remove. Let's say we want to remove 8, right? So we remove 8, and then we print the list. Now we don't need this anymore because we're just trying to print out the whole list this time. So if we remove the element 8, you see now that the object 8 has been removed, and we're only having 3 elements left in the list. Now let's assume we do not know the elements in the list, right? But we want to remove an element, or we want to remove elements where according to a condition. So let's say we want to remove all elements that are less than 8. Yes, let's say we want to remove all elements that are less than 8. Now for us to do that, first we have the list.remove, and then we want to remove elements on the list where the, so we have list where the element is less than where the number, because this is a list of integers where the number is less than 8. So we'll do list the element at, so list or remove first, and then within list or remove we're going to do list dot element at. Now the index can take in, and so we have now list dot element at. Now for the index we're going to go list again dot index where. Right, so index where takes in a function. Now it's telling us, okay, this is the element. So this element, we want to look at what's that element. So if the element is less than 8, we want the list to remove that element for us. So we save this and then we run, and when it runs and prints out the list, now if you look at this, you see that it printed out 8, 9, and 6 for us. Now the reason is because we only executed this once, right? So if we execute it again, let's say we do it again, like let's take a look at the example we have here. It says removing elements that where the word starts with R, so it had to do it twice, right? Now if we do this and run again, you see it took out that for us. Now we'll probably get to this later when we talk about featuring in lists, how we can do all of this at once without having to run the same code twice. Now, while still on adding elements to a list, let's say we have more than one list we want to combine, right? So we have another list of integers, and it's saying numbers, and the numbers are 2, 3, 4, 6, 7, and then we want to add the two lists together, right? So all we do now is we come here and say list of integers again. And now we can just call this combination, and for this we're going to use what we call the spread operator in Dart. Now the spread operator is just 3 period signs, 3 periods, and then or full stops, and then you give it the name of the first list you want to add, and then another one, and the name of the second list you want to add. So when you do this and come over here to print combination, you see that the combination is then going to be both lists put together. So this is what we have, right? Now let's look at how we can filter lists, right? You know, earlier when we were trying to remove an element from a list, we had to do it twice to remove all the elements we had in the list. Now for this, we're going to work with combination now, because we have both lists put together. I want to be able to remove elements from the combination list itself, right? So we're going to write a function that will be able to run through both lists and then print out the elements that are, let's say, greater than 2 or greater than 5. So we're going to work with greater than 5. Now, for you to filter a list, you can use either of two methods. One is remove where and the other is retain where, right? So when you remove, you can then reassign the list. But I like to use retain where, because with that you can simply keep just those ones, right? And then you can add them to your new list. So let's say we want to we'll create a new list now. We'll say final filtered list. Filtered list is combination dot retain where. So now for the retain where method, if you look here, it tells you that it takes in a function, right? Now we can just put that function here and say we want to retain where the element is less, okay, we said greater than, right? Greater than 5. So when I do this, my new list now, which is the filtered list, is going to contain only elements from combination that are greater than 5. So if we come over here and print filtered list, we're going to get only elements that are greater than 5. Okay, there's a little issue here. So first we have to assign filtered list to combination. So filtered list is combination, and then now filtered list is what we're going to put here. Right, so filtered list is first made the entire list from combination, and then we'll filter that list and we get our result and print it out. So we'll come here now and run this. So what happens? So it goes through the list. I think I'm going to do something, right? I'm going to print combination first before printing filtered list, so we can see both together. All right, so save this, run. Oh, sorry, I have to take this up here. Where is it? Okay, print combination here. All right, so now that we're printing our combination first and then printing out filtered list as well, we can see what we have on both. So we have, when we print that, we're going to have this now is combination. That's the combination of both lists, where you have all the elements, and here you have the list that only has the elements that are greater than 5. So this is a simple way to filter lists in Dart. Now for our next collection, we're going to be looking at sets, right? Now a set is almost like a list, or a little different. I think I'm going to leave this in so we can use, okay, we're going to use the combination now, right? So simply you can convert a list to a set, and then a set back to a list. But the difference between both of them is that while lists are a group of elements and they are ordered, you can have them. You can have the same element appearing more than once, and there's no problem. You can see clearly here we have 6 twice, and so on. So, but for set, when you have a set, every element has to appear just once. So a set is a group of unique items, right? So it's like a list of unique items. So let's say we want to make this combination a set now. So we can just print combination dot to set, and then we can leave it this way, but I like to take it back to a list. Now this will give us a list of these items that are unique, so no element appears more than once. So you see now for the first one we had 8, 5, 8, 9, 6, and then 6 again here. But if you see here, we have 6 appearing just once because we're now making this unique. Now to create a set from scratch, we're going to take all of this out. To create a set from scratch, we're going to have to go with the keyword set, and then you can give it a type as well. So a set of integers, say let's say set is, now a set is declared with curly braces like this. So when you have curly braces like this and you have this, you have a set. So this we can have 1, 2, 3, 4, 5. Now let's try and put 5 again and see what happens. Now there's a squiggly line under, and it's saying 2 elements in a set literal shouldn't be equal, so they cannot be the same. Now while this is not stopping our program from running, when it runs, this set will be returned as 1, 2, 3, 4, 5. So this will not even be seen as a member of the set. All right. Now we can do the same for strings. So a set of strings. So let's say we have names, right? And I'm going to start with my name, Maro. And let's say we have another person called Maro as well. And then we have a James and Jane. Okay. So if you have this, you can print out this, and you see it's only print out Maro once. So if we come here now and say print names and run this, it prints out Maro once, because for a set, no matter how much you try to force it, it's not going to give you the ability to declare an element more than once. So if you have the same element and you're trying to add the same element again, it doesn't work. So sets are useful when you're trying to make elements unique when you get them maybe from a list. So you can just convert the list to a set. Once you do that, it automatically becomes unique, and then you can take it back to a list. And then we're going to look at maps. Now maps and sets are declared almost the same way, right? So for a set, let's say we have the final keyword, and we say set, and we give it just those curly braces. You see, it looks at this and says it's a map of dynamic to dynamic variables, but we just said sets are declared this way, right? Now for you to ensure that this is not seen as a map, since maps are also declared with curly braces, what you do is you're going to give this a type, right? So when you give this a type here, say string, it then sees this as a set of strings and no longer as a map. Because if it was a map, you then have a map of string to string, right? So this is a map, but the other way, it's a set. So now let's move over to maps. Now maps are an arrangement of key value pairs, right? So a key to a value. So let's say you have name, Maro, age, 20, sex, male, and all of that. So we're just going to create a simple map now. Now you can create a map as simple as this. You have map, and this is going to be a map of dynamic to dynamic variables. So when you create a map by just typing the map keyword and you do not add anything else to it, it just automatically creates a map of dynamic variables to dynamic variables. But generally, we want to create a map of strings. Let's say strings to strings, or strings to dynamic variables. So I like to create a map of string to dynamic variables. So the first type declared here is your key, and the second type declared is the variable, the value. So let's say we have different keys now, right? So we have name. You separate them with a colon, and then you give the name of the person, and then you have the next key, which is age, and age is 20, which is a number. It accepts that. Separate with a comma again, and then you go sex, and it says male, right? And it accepts that as well. So this is what a map looks like in Dart. Now, for you to access different elements in a map, just like we had to access elements in a list, you can also use the square brackets. So you say print, let's say we want to print out the name of this user. We say print, and then we type the name of the map, which is map in this case. And then within square brackets, we add the key we want to print the value of, which is name, right? So we want to print the name of this user. We're going to clear this so we can have space to work all over again. So we have Dart play Dart. Now this prints out Maro, which is the name of the user. Now this looks at this map and checks if the key exists, and if it does, it prints out the value of that key. Now if you try to print a key that doesn't exist, it's actually going to return an error. So let's just try that. So let's say we're trying to print gender instead of sex that we typed in there, right? So if we run this now, it tells you it's null, right? Now it's null because it is not available. So there's no key that has the text gender in this map. So it checks, doesn't see it, and tells you, oh, sorry, there's nothing like that. So it's empty, it's null, right? Okay, so that's that for that. So now we've been able to look at lists, we've been able to look at strings, at sets, and then we've been able to look at maps.
Thank you very much for watching. See you in the next video. Please do not forget to like, share, and subscribe.